Alex Cole here from BobCAD-CAM. So in this video, what I want to take a look at is using a wrapping group and some of the common problems that we see people contact in to support and have questions on because they're kind of confused in how the wrapping group actually functions. So what I want to do is try to solve some of those confusions and help you guys to understand how the wrapping group works so that you can know when to use this path and what it's good for when cutting slots on a 4th axis rotary. So I have a common type part on my screen here. This is simply a 1/2 inch wide slot that has been cut through a tube. It's about a 250 wall tube. If we look at the side view here and I turn on transparency and we take a look, we can see that the walls of this, the walls of the slot are straight up and down. Now it's important to recognize that and understand when that is the situation on your parts, because you may or may not be able to achieve the desired result using the wrapping group, and you may have to go to a more advanced 4-axis toolpath to be able to cut your part. So let's go ahead and dig in and take a look at this part. Okay, so with this part, what I'm going to have to do first is go ahead and add a wrapping group to our machine setup. I've already got a machine set up for a 4-axis VMC vertical mill with the rotary that's rotating around the x-axis. So we can see my machine setup here is oriented at the right end of the part with z-axis going up, x-axis pointing to the right. Now it's important to point out real quick, for those of you that don't know, in your machine setup, this work offset XYZ, I want you to notice that I have a -5-inch value. So 5 inches to the left is where it's going to be positioned on our machine for simulation. And that just keeps our part from being butted right up against the faceplate of the rotary in simulation so that we don't show the machine crashing. Okay, so let's add a wrapping group. And when I come in, I can go down to additional functions. I can add a wrapping group. And we need to define the parameters for this wrapping group. So the geometry that we're going to be using is the actual edges of these surfaces. I do have that wireframe broken out on another layer, and that's what we're going to select. But that geometry is already wrapped, meaning that it's 3-dimensional and it's not on a flat plane. So we need to select the wrap geometry option. The next thing that we need to define is what is the diameter of our wrapping group. So in this case, I've already defined this using the tube style stock, and that's a 2-inch diameter. So we're going to go ahead and say OK to this. So this wrapping group has been defined, and then any features that I create under that wrapping group are going to have those wrapping parameters applied to it. So right-clicking on the wrapping group, and I'm going to select Mill to Axis. So in my geometry selection, I'm going to go ahead and go to my wireframe layer and turn off my surfaces. And here you can see the wireframe that we have, and I'm going to go ahead and pick this top wireframe geometry, and we're going to see it gives us our preview, and by default we're going a 1/2 inch deep. Now one thing to keep in mind here, this tube is about 250 thousandths deep. If I set this to 250 thousandths, if we look, we can see very quickly with this geometry preview that that's not going to be high enough to break all the way through our tube. So I'm going to go ahead and extend that a little bit beyond, and I'm going to say 375 thousandths deep to extend that tool down to where we have plenty of clearance through the interior of that tube. So I will say OK there. For this particular example, we don't really have a need for two different operations. So I'm going to get rid of our profile rough operations on the machining strategy tab. And we'll go ahead and get into the parameters. The first obstacle that people run into, and I'm going to start by picking a smaller diameter tool or entering a smaller diameter tool and show you the results that we get using the smaller diameter tool. And then we'll change tools and look at it again. So right now I've picked a 250 diameter, and I'm going to leave all of our other parameters at their default for right now because I just want to take a look at that path. So when I compute this path, I can see that the tool is going to come in and it's going to walk around the walls of this part, rotating up, rotating around, and everything visibly doesn't look too bad. But what I want to point out, I want to turn on our surfaces so that we can see them. And now I want to look at this thing from a right side view where we're looking down along it. So a wrapping group, what it's designed to do is it's always pointing that tool at the rotary axis. And it's very important for you to understand what that means. When we looked at this earlier, we determined that our slot was straight up and down, which we can kind of see here, right? We can see that our slot was, I keep rotating this thing, sorry. So our slot here, the walls of the slot are supposed to be straight up and down. And we can clearly see that the tool is pointed directly at the rotary axis center. And that is the way that the wrapping group works. That's what it's intended to do. So using a smaller diameter tool than the width of our slot is going to result in angled walls on that slot. Now, if we switch to a larger tool, in this particular case, the width of the slot is a 1/2 inch. So we would be able to switch over to a 1/2 inch tool and try to cut this slot. But I wanted to show you, this is the biggest confusion that people have about using a wrapping group, and that is a wrapping group is not a true 4-axis tool path where it's going to keep that tool and move it off of center line. When we're rotating around X and we're cutting, we will be moving the tool in X and Z, and then instead of there being any Y-axis motion, what happens is the rotary is going to rotate. So Y is always going to stay on 0, and that's the way that the wrapping group is designed to work. If you need to cut that thing where the tool needs to move off of Y0 in this case, you would have to go to one of the 4-axis Pro tool paths and utilize some of the strategies there. So let's go ahead and take a look at putting a larger tool in there and see what our results are. So going in here, we go to our tool, set this to a 1/2 inch diameter, and let's go ahead and compute this. So one thing I want to point out right away is that I'm getting two different vertical lines here. So zooming out on our part and rotating around, turn transparency back off, I notice that there's two parallel lines here. Now I know the width of this slot is a 1/2 inch, and I just set my tool is also a 1/2 inch. So this is indicating to me that I'm probably going to have some sort of a problem. Now, based on the tolerances of your part, this may be acceptable, but you do need to be aware that driving a tool in a pocket like this with a wrapping group, you can potentially run into tolerancing issues. We're using wrapped geometry, and in our wrapping group, there is an unwrapping tolerance that's being used to construct and do calculations in the background. Now, changing this tolerance may or may not fix the problem that you're running into, but you're more apt to run into a problem like that trying to get that exact fit tool in there. So what I want to do is I want to simulate this part and take a look at exactly what the result is on this path the way that we have it right now. What we're going to see is, all right, so we have our machine here, we have our tool, we've got our material. So as I bring this tool in and it plunges down, so we've just swept down the one side, and then as it cuts around, we can see there's like a little rotation there. And I have both the stock and the workpiece visible. And where we're seeing the bluish color is the stock, and where we're seeing the gray color is the workpiece. So being that this wall is solid gray is telling me that we may be running into that workpiece. And looking at the other side as well, I can see that the same thing is happening on that side. That's because we're making those two passes. And again, based on the tolerances of your part, that may be acceptable. Noticing how when we're sweeping down this side, we're getting very clean cut. Even though it is making a pass down and up, I can see that this wall, because I have that mixture of the blue and the gray, that's telling me that the cut surface is right on top of my part surface. And the same exists for this wall. So that tells me that this portion of the cut appears to be spot on and very good. However, looking at these walls up here, that's indicating to me that we're actually cutting a little bit extra material. So what can we do to fix that? So let's look at a second approach of being able to use this path to create this slot kind of the best way possible. So this involves a little bit more work, and I've created some geometry on other layers just to save time for this video, but the principles all apply the same. So I'm going to blank this tool path so that we don't have to see it, and I'm going to show you on another layer here called center surface. I simply took this edge and I extruded, and I used the extrude curve option to extrude that edge in both directions. And by doing that, that's given me a floor surface that's right at the small diameter for this tube. Now from there, I then created geometry in two different planes. From the top plane, I created a line that runs right down the center of my channel, and that line is trimmed right at the center of the arc at this end of the channel. And then from the front plane, if I turn shading off, you'll see that I created a vertical line that also runs from the center of that radius past the top of the actual surfaces on the part. Now, once I had that geometry, I used that geometry and I project it onto the surface that I had created for that center tube. And my result, if I turn off all these surfaces and the wireframe, the result is this geometry here, which represents the exact center of my channel that I want to cut. So if I use that geometry, if I remove my existing geometry and I reselect and I chain that, right, and I can reverse that chain if I want to and say OK, and now compute this path. The resulting tool path is going to be right down that chain. Now, what I just ran into here is because before we started with that smaller tool, we were using compensation, and that compensation is still turned on in our operation. So I will edit the parameters. I will go to the patterns page. Under system compensation, we have left turned on. I'm going to turn that off, and I'll hit compute. So now what we end up with is a single clean pass going right down the center and a single clean pass going right around that curve. So if we backplot to verify that, we can see that it's one cut, and out. So it's a nice, clean, efficient path. Let's see what it looks like in simulation. So it does take a little bit more to create that geometry, but if you need that accurate cut in this scenario, it's what you're going to have to do. So here the tool comes in, it cuts down the slot, and then it cuts down the curve. So let's turn on the visibility of our workpiece. Since in that case, I don't know if you caught that, my workpiece option was not available in simulation, and that's because the surfaces were not turned on when I launched simulation. If you don't have the surfaces visible, then when you get into simulation, you won't have the options to turn them on to make them visible in simulation. So we'll go back, turn those surfaces on, relaunch simulation here, and now this time we should be able to see our workpiece, which there it is. So stepping this through, I can see the plunge going in, and I can see that mixed shading of both the gray and the blue on our walls there, which tells me that we're cutting right to that surface. Okay, and then we'll go ahead and let this track down the side. And looking at this, now I have that nice surface that's showing me both the workpiece and the cut stock, and they're matching perfectly on everything. So it took a little bit more work to create the geometry to get the perfect slot into this piece. My walls are straight and they match the model, the way that the model was drawn, but the only way that I was able to cut that was because I was using a tool that matched the width of that slot. If we go back here just real quick to drive this point home, with a 250 thousandths diameter tool, so a smaller tool, right? Let's compute this, let's backplot, and see, oh, I gotta reselect my geometry. So we will go to wireframe, I will change that wireframe. I will get rid of my other chain. Kind of goofed that one up a little bit there. Okay, so put my start point over there, compute, and take a look at that. So again, with a smaller tool, we're not going to be able to cut those vertical walls because they don't match the actual part. So we can see the walls on the part are supposed to be straight, but this tool is always going to be pointed at the center of the rotary axis. And that's why with a tool that matches the width of that slot, we're able to do that because the center of that tool can point at the center of the rotary axis. So you have to evaluate the geometry that you're trying to cut and understand that this tool will always be pointed using the wrapping group to the center of the rotation axis. And you'll have to determine whether you're able to cut your geometry using this method or not. But hopefully this will help you understand so that you can recognize those situations quickly and be able to know what toolpath to use right away to be able to accomplish what you need on the part that you have. All right, that's all for now. Thank you.